Welcome to Instigators of Change, a Khosla Ventures podcast where we take a look at innovative ideas, the people who come up with them, and those who invest in them. I'm Kara Miller, and today, tough talk on cancer, which has been a top killer in America for decades.
In the 2000s, the idea was that, we would sequence cancer cells, find genetic mutations in them, and then find drugs that target those genetic mutations.
The physician and writer Siddhartha Mukherjee says that idea mostly fell flat, and it's time to admit we badly need something new.
We have, as a community, have to acknowledge that. If we don't acknowledge that, we will be not a scientific community, but something else.
Mukherjee and Anand Parikh, co-founders of Faeth Therapeutics, talk about a different way forward.
We're not going to chemically engineer our way out of this problem. I think we've got to think orthogonally and really do the physiological work to starve these tumors.
That's just ahead on Instigators of Change. After Neil Armstrong landed on the moon in 1969...
It's one small step for man, one giant leap for mankind.
Richard Nixon triumphantly announced, and this was just a couple of years later, what became known as America's cancer moonshot. The goal being, as Nixon said, the conquest of cancer.
It's a little bit like saying, we're going to send a rocket to the moon without knowing Newton's laws.
Siddhartha Mukherjee is a physician focusing on cancer and an assistant professor of medicine at Columbia. He won a Pulitzer Prize for his book on cancer, The Emperor of All Maladies.
When the cancer moonshot was launched, we understood very little about cancer. This was a time when there was a big debate about what cancer is as a disease. Is it a viral disease? Is it a genetic disease? Is it a combination?
Treatments were also perplexing to doctors and researchers, and there was a real danger to this moonshot, Mukherjee says. People thought, kind of like the actual moonshot in the 1960s, it was going to result in something concrete. We had landed on the moon. Maybe now we would conquer cancer. But then we didn't. So here are the stats. More than 500,000 Americans die of cancer every single year. Mukherjee has become convinced that we just have to do something different. And that, he says, means looking back at some very old research, which may never have been really embraced in the way it should have been.
Almost 100 years ago, starting with work done by Otto Warburg, there's been this idea that in terms of metabolism, cancers share very, very different cancers. Breast cancer, leukemias, pancreatic cancer share a metabolic dependence on nutrients.
So what if you could figure out how cancer cells, which behave differently and deal with energy differently from other cells in your body, what if you could figure out just what nutrients the cancer cells need to thrive and then not let them have those nutrients? Mukherjee is seeking to answer that question as a co-founder of the company Faeth Therapeutics, along with several fellow researchers and physicians. Anand Parikh is also co-founder of Faeth Therapeutics, where he serves as the CEO.
The research base is becoming overwhelming that this is almost certainly a new therapeutic approach akin to surgery, radiotherapy, or drugs, that precision nutrition is just waiting for its time in the sun as it relates to cancer treatment.
And just go further on that. For lay people, what the heck is precision nutrition? And what have people found in the lab? Like, what kinds of manipulations of nutrition have they done, and what have they done to the cancers?
Yeah, I think these are very specific manipulations intended to look at what's the organ of origin. So as Sid said, is it breast cancer? What's the prevailing genotype? Is it HER2 positive? What's the drug that's being used to treat this cancer? And then we look at the nutrients that are needed by that particular tumor type. And that's where we find the commonalities that Sid was mentioning. And, we've seen research on things as varied as serine and glycine deprivation, insulin deprivation, histidine supplementation, methionine, these very specific nutrients. We find that particular tumors or particular groups of tumors, as Sid alluded to, have a excess reliance on these things, and that if you take them away, it harms them. And what we've seen in many of the preclinical studies is tremendous outcomes. In some cases, greater than we would see with traditional drugs. Literally, diet being more powerful than chemotherapy in preclinical models in pancreatic cancer. A horrible disease that now we're hoping to bring some potentially new treatments to.
Sid, let me switch over to you. When we think about these really obscure nutrients that many people have never heard of, what does it mean to an actual patient to try to deprive this cancer mass in their body from getting access to one of these nutrients that apparently the cancer does really well with?
Well, first of all, let me just say that these are not obscure nutrients.
Okay. We may not have heard of them, but it doesn't mean they're obscure.
Yeah, these are fundamental nutrients that cancers and our bodies depend on in order to function physiologically. So these are nutrients that we can manipulate because our body can make them, but cancer cells are uniquely dependent on them. I often like to use the analogy of the Achilles heel. Cancers have Achilles heels too. We just have to find the Achilles heel. And these are nutrients that our bodies can make, our bodies can survive with, our bodies can even survive without because we can make them ourselves. But cancer cells are uniquely dependent on them. If you deprive them of the nutrient, the cancer cells shrivel up and die. So I really think about nutrition as a completely novel axis of oncology, of cancer therapy. It's never really been fully explored, and it's a novel axis. It's an axis that really lies outside the traditional sort of chemotherapy, radiotherapy, surgery axis, because no one has, aside from, experiments done 100 years ago, no one's really fully looked at how important it is for a cancer cell to have nutrients, because nutrients are the ways that cancer cells grow. There's no other way. There's no other mechanism by which they can grow.
So just on a practical level, what does it mean for Joe, the cancer patient, not to have, glycine in his diet? What does it practically mean for this person who has cancer? What do they do on a day-to-day basis?
It means changing the diet, but let me emphasize that these are not radical diets. These are diets that we've devised and are continuing to devise that have to do with very particular manipulations. And these very particular manipulations have to do with, maintaining normal diets, normal nutrition, normal energetics, but with something that's different.
Okay.
And those differences, I think the emphasis is on the fact that these are tolerable, achievable. These are not like, you go on some crazy blueberry fasting, et cetera, et cetera.
Okay.
These are very specific precision diets, which almost mimic your normal lifestyle, except, and you wouldn't notice it, but the cancer cell would notice it. Anand, do you have any thoughts about it?
Yeah, I think that's very fair. And I think, Sid mentioned the variegated nature of all these tumors, and the diets are just as multitudinous, right? It will be different for each particular group that is taking a particular intervention, dietary intervention. It will be different. The precision nutrition will be different. So whereas someone who is being deprived of glycine may have a particular type of diet. Someone who's being deprived of cholesterol, well, theirs will look very, very different. So there are differences there. I think one thing we've tried to do as a company is, as Sid mentioned, make it as easy as possible on the patient. So we will send them literally everything they need to their door to make it as absolutely easy for them to comply as possible.
Underlying all of this, it seems clear from what you're saying, is this idea of precision, that like everybody's different. So it feels like underneath all the food and thinking about amino acids is a pretty hefty level of, I think, this wave that we're kind of part of, this idea of precision medicine, of like using computers to figure a lot of things out about who needs what. Is that fair?
I think that's absolutely fair. And I'd like to draw a line. You know, Sid sort of talked about Warburg and his initial work in the 1930s, and then how Sid and Lou and Karen and others have been publishing papers over the last 10 years, you know, showing how thinking about organ of origin, genotype, and drug can provide us with a level of specificity that maybe Warburg didn't foresee. And I think in the future, once the FDA is able to contemplate this, I think we're not just going to see, you know, small slivers of people on very specific diets. I think we're going to see N of 1 precision nutrition. So that the breast cancer patient, the two patients who Sid mentioned who have breast cancer but are very different in terms of their mutational status, in terms of the physiology and the etiology of their tumor, will have slightly different precision nutrition prescriptions. And, you know, the way we figure all of this out, because I think the data is so voluminous that it's too difficult for any one person to comprehend, is we have a machine learning system that literally spits out the difference in every single phenotype, genotype of tumor, and the difference between use and production in nutrients. And from that, we can then surmise that a particular tumor will have different needs than another one that otherwise might look quite similar.
So this could be for either of you. And it's a bigger question than Faeth, because if so much importance is placed on kind of the machine learning, the data analysis that has to be done, because as you said, like there's so many inputs, no person's going to like sit down and compute this. Are we there yet with like how good data analysis is, how good machine learning is? Because I think people think of curing cancer or getting further with cancer as like, you know, reliant on men and women pipetting things in a lab, right? But we're really talking about a different set of tools. And I just wonder how far along you think those tools are.
We're talking about the both of those tools together. So we're talking about, you know, using machine learning to help stratify the world of cancer, and then using experiments in the lab to further drill down and validate. So I think it's a mix of both. The other thing I would say is that even if the machine learning isn't good enough today, or isn't where we would want it to be perfect today, unfortunately, neither are cancer drugs, right? So we sort of see this situation where I was thinking about a drug called Enhertu that got a standing ovation at ASCO with a 40-odd% response rate. You know, there will be, we won't be perfect in having every patient respond to a particular precision nutrition intervention. But even if we break those, you know, sort of 30, 40% thresholds, it can be practice changing for many diseases.
Sid, what's your take on this?
Well, I would echo Anand's ideas, and I would say that's not 40 or 50%, because it will likely be more. Because what we're targeting are not particular mechanisms or genetic mutations that drive cancers. We are targeting the general physiology by which a cancer cell grows. And that's been, you know, the holy grail to some extent of cancers. in the 2000s, the idea was that, we would sequence cancer cells, find genetic mutations in them, and then find drugs that target those genetic mutations.
Right.
That was the big idea.
Right.
That idea, I think, has turned out to be, aside from a few cancers, a great disappointment. And we have, as a community, we have to acknowledge that. If we don't acknowledge that, we will be not a scientific community, but something else. I'll give you an example. After about 2 decades of research, a drug was created around one of the biggest drivers of cancer called KRAS. It was a drug that was specific to that mutation, and it was specific to the idea that that mutation would drive the cancer's physiology. When the drug was used in a clinical trial, it was a positive clinical trial, all good, but the progression-free survival was, nothing that one would applaud. 12 months, 18 months, I don't remember the number. This is a reminder that cancer cells are incredibly plastic in terms of their capacity to resist drugs that are targeted to the mutations that drive their growth. And I would say that we as a community of oncologists have turned our heads away from the idea in the 2000s and 1990s that, there was a linear idea. Find the mutations, target the mutations, kill the cancer cells, end of story.
Right.
It has not worked out to be that. So we need a new paradigm. And the new paradigm is to say that, that old idea was a good idea, but it wasn't right. And so we need a new paradigm. And the new paradigm has to be that we need to target fundamental physiological mechanisms in a cancer cell that are different from a normal cell, and thereby target cancer. It's a completely new idea. And I cannot emphasize how revolutionary and how much of a difference this is in the standard thinking about cancer. The standard thinking about cancer is, you have cancer, sequence it, find the mutations, and find the drugs that will target the mutations.
Right.
That has not worked. It has not worked not only with minor mutations, it has not worked with mutations that are known to be the major drivers of the cancer cell. So we can put, like ostriches, our heads in the sand and say, let's go on this way. That has not worked. And if we keep putting our heads like ostriches in the sand, it will keep not working. We need to find a new way forward, which lies outside this kind of linear logic of find the cancer, find the mutation, and find a drug that blocks the mutation. That is not working.
One thing I would add, I think what Sid said is so important because it totally undercuts the prevailing orthodoxy. And I think it takes a lot of courage, and I'm not sure there are a lot of people with enough courage to say what Sid just said, that essentially ever more fine-grained discovery of smaller and smaller mutations and better chemistry is not going to solve this problem of cancer. We're not going to chemically engineer our way out of this problem. I think we've got to think orthogonally and really do the physiological work to starve these tumors.
And let me add more to that. I've tried to understand the prevailing orthodoxies, and I've tried to reconcile myself with them. And no one was more excited than me when we found a drug that would target one of the great mutations drivers in cancer like KRAS. And yet no one was more disappointed in the results. And so we have got to change. we have got to think of new paradigms.
Do you feel like it's an issue of sort of ignoring something that's systemic? It sounds from what you're describing like you've got a building and people are looking for the brick that's messed up. But in fact, the problem is like the air conditioning system. Like it's something that is not confined to just one little place. It's more part of how the whole entire system works.
I've been saying this for forever. I think that cancer is a physiological disease. The cancer cells are physiologically different from normal cells. And the more we explore that physiology outside finding mutations is the best way to move forward. I wrote a piece in the New York Times called "Cancer Should Not Be About Mutation Hunting." Cancer is a physiological disease. Most diseases, every disease that we know of, is a physiological disease. By physiology, I mean it integrates multiple aspects of human biology. There are signals that go between cells. These signals can counteract or even inactivate drugs that we send with great precision to cancer cells. And cancer is one of them. So I stand by my belief that unless we understand cancer at a physiological level, we're not going to move forward.
Anand, let me ask you a little bit about food. One of the things I've found over the years as I've spoken to different doctors, different researchers, is that food, even though we know it is very important in keeping you healthy, it's often doesn't get that kind of credit. I mean, there have been, like little programs where doctors are allowed to prescribe vegetables and like you might be able to get those for free. But if you find that food really can help with cancer, how do you get a sort of establishment that's really about pills and other kinds of medications to accept food as part of like health and medication?
I think that's a great question. I think the first thing is proving efficacy. If you can prove that this treatment modality can deliver outcomes that are, of the level or greater than traditional therapeutics, I think there will be a groundswell from the patients themselves saying, look, this is something we need to have access to because it's going to help us live for longer and potentially cure disease. And so I think in many other disease states, the power of food is already recognized. You look at diabetes, you look even at cardiovascular disease to a degree, you think about inborn errors of metabolism, irritable bowel syndrome, pediatric epilepsy. There's a variety of diseases where we do acknowledge and understand the power of food in either managing or treating those diseases. I think it's only a question of time until it comes to cancer. And once it does, and if it demonstrates efficacy of the same degree or greater than drugs, then there's no reason why it should not be paid for at parity in the same way. I've often said this and I often, repeat it, but I really do mean it. I hope that if Faeth is successful, that we have 100 competitors very, very quickly, because we alone will not be able to do the work needed to truly explore this entire new axis of treatment. We need a lot more people in the space very, very quickly.
And just to add to Anand's point, food is a chemical. Chemotherapy is a chemical. Targeted therapy is a chemical. There is no fundamental difference between food as a chemical, chemotherapy as a chemical, targeted therapy as a chemical. These are all the same things. They just come by different names. If a chemical or an enzyme like L-asparaginase can deplete asparagine in the body and thereby really make a difference in pediatric leukemia, there's no fundamental reason why depleting asparagine in another way, whatever it might be, could make a difference in pediatric leukemia. They're just chemicals. And the idea that food is not a chemical is absurdity, because of course it is. So my general point is that as a chemical, food has been underexplored and should be more deeply explored as one other axis of chemical therapy for cancer, in which we are not dependent so much on, as I said, the find the mutation and find the drug strategy, which has not worked.
And I think one other thing to add to that, the precision nutrition interventions we're talking about, Kara, are not things that generally an individual can do by themselves.
Okay.
Earlier on, you said, well, what would an example be?
Right.
If you're depleting serine, glycine, and proline, nobody's going to have any idea where to start and how we do it.
Right. Does that mean I order pizza or pasta? Like nobody knows, right?
And it's not that simple, right? So it is a chemical. In many ways, it looks and feels to the patient like food, but there are drug-like components to it as well.
Do you see precision nutrition as doing the heavy lifting here? Or is this a situation in which, I know there have been studies where, let's say a diet, like a keto kind of diet, has made a drug much more effective because that kind of diet appears to sort of pave the way for a drug to actually work. You know what I mean? Can you give me a sense of, is this an in conjunction thing or is this an end in itself?
I think it can be both. I think in some cases, you will see precision nutrition that makes adverse events disappear and that makes the drug more effective. I think some of Sid and Lou's work has shown that. I think in other cases, you will see that the nutrition itself can be a very, very valuable therapeutic strategy in and of itself, which Karen Valsden and Oliver and others have shown as well. So I think it can be both. I think it just depends on what's needed.
You both think that this area of cancer research is really promising. If you look out 5 or 10 years, does food feel to you like the most exciting area? Are there other sort of realms that are also being explored that you find like these are also really promising paths into, cancer research?
Well, I think that, immunotherapy showed us something very important. And again, let me emphasize this. What we learned from immunotherapy against cancer, using the immune system against cancer, is that you didn't need necessarily to sequence every tumor because the immune system was largely agnostic to what sequences, what genetic mutations the tumor had. The immune system reacted to the changes, the physiological changes in the tumor itself. Things that didn't have to do with whether it had a mutation in KRAS or DNMT3A or whatever it might be. I think more and more we are moving away from a time in which we're saying to ourselves, yes, precision medicine is important, but precision medicine is not the sequencing of tumors. It's something much broader. It is understanding the physiology of the tumor. What does it depend on? One tumor might depend on its capacity to draw out blood vessels. Another tumor might depend very highly on histidine. Yet another tumor might depend very highly on glucose metabolism. And so the way I see moving forward is really understanding precision medicine not as what I call sequencing medicine, and moving forward in a way that we understand precision medicine as a mechanism to understand the brain of the tumor, the mind of the tumor, the physiology of the tumor, and using that as a mechanism. And of course, nutrition is absolutely central to that idea.
Anand, do you think of what Faeth will provide to patients as being like when you go on certain diets, all your meals are prepackaged and sent to you? Do you see that as being like the thing that you give to patients?
Yeah, so I think what Faeth does and delivers to patients is a tripartite approach. What we do is we have precision nutrition, we have drugs, and we have software, and we wrap them together in that unified package.
Okay.
So we do all of them. We make sure that the drugs we're providing, work with the precision nutrition as well, and that they're both optimized for each other. But that's what I anticipate that these patients will be getting from Faeth.
Okay. Do you think because there's a big piece of this, it's food, and maybe in some cases, for some people, it's just a food thing, could this be cheaper than other treatments? Because one of the real problems we've seen with cancer drugs, especially in recent years, is they're just phenomenally expensive.
I think unfortunately, so I hope that they can be cheaper.
Okay.
I think in manufacturing, because we are actually manufacturing food, to a degree, they will be more expensive because, manufacturing each additional pill is pennies. Manufacturing a meal is not. But I do think that a lot of that will go to the FDA. The overwhelming cost in drug development is sort of in the clinical development of the drug. It's not actually in the manufacturing. It's mostly in all of running the trials, the regulatory hoopla, and all of that stuff. So I do think that in the future, with this treatment modality, if the FDA can start thinking creatively, that we could then be able to bring treatments to the entire globe that are much, much cheaper than traditional treatments. I think that's the other great thing about this approach, right, is that immunotherapy and other biologics are quite difficult to manufacture and administer outside of sophisticated medical systems like in the US and Western Europe. I think our intervention has the ability to be delivered in almost any setting, theoretically.
And then a final question for both of you, which is, give me a sense of the timeline here. Like, how are you going to know when things work? If people are listening and they're very interested and they agree, yes, we need a different approach to cancer, what does that road ahead look like?
The timeline is now. We are already deploying. We are already making diets. We are already combining them with targeted therapies. The timeline is now. It'll keep being now. It'll keep being now more. But Anand can answer it more. But we are in the middle of trials.
Okay.
That's right. I think, we're very, very excited about the trials that we have ongoing. But I am hopeful that in, the next 12 to 18 months, let's say, that we have data in our hands that can show the entire world, academic or otherwise, that precision nutrition can be this fourth pillar of cancer care, as Sid mentioned.
And will those results in 12 to 18 months allow you to move through the door from trials to like the wider world?
They will allow us to move from, I would say, mid-sized trials to really large trials that will prove definitively the value proposition. Now, that's my assumption, but that will ultimately be, of course, up to the FDA.
And then if everything were to go well, how long would it be, do you think, from now that something would actually be on the market and a doctor somewhere could say, well, you have this cancer and we're going to use Faeth? Like, how long would that be, do you think?
Hate to hazard a guess at that because we're ready. The company is ready and ready to execute. It's really in the hands of the regulators to a degree. So I'm hoping in the next few years, in the next 2 to 3 years, that we can kind of be at that point. But ultimately, it will depend on what the regulators need to see to believe.
Got it. Okay. Anand Parikh is a co-founder and the CEO of Faeth Therapeutics. Sid Mukherjee is also a co-founder of Faeth, as well as a Pulitzer-Prize-winning author, a physician, and an assistant professor of medicine at Columbia. Thanks so much to both of you.
Pleasure. My pleasure.
Thank you, Carol.
And thanks, as always, to you for joining us. Coming up next week,
we find that for successful venture capitalists, they actually aren't very swayed by charisma and passion at all. They actually look for that rationality and a clear and well-explained pitch more than anything else. So I just would urge people to think about, even if they think they're not good at some of the skills that they might think they need for startups, that doesn't mean they can't be successful.
Subscribe to Instigators of Change wherever you get your podcasts and leave us a review. Our show is produced by Matt Purdy. I'll talk to you next week.